Hi guys, in today's video we are going to see how we can use the video which is taken from our mobile phone, in our case it is iPhone, and then create a Gaussian splat using that. So this is the GitHub repository where they have explained the whole process, how we can use the repository to create Gaussian splats. And also in our video today, once this Gaussian splat is created, we are also going to visualize in the Gaussian layer which they have explained, and also we are going to import it in Unreal Engine so that it can be used for gaming purpose or any other use case. So that is all being covered in today's video. So let's get started. So first of all, I'll be showing you the video. So this is inside the RML Office 5 folder, and this is a video of our office that I've taken, which consists of our there are two rooms within the office, and this is a terrace part where also you can see there are clothes hanging. So this is the recorded video which I've taken. So I've taken multiple rounds of the terrace as well as the room inside which we work, and now we are going to create a Gaussian splat of this video using the technique described in the repository. So this is the original repository, but I found one other repository which specifically talks about how you can set up the Gaussian splat in a Windows system. They have thoroughly explained all these steps, and I followed these same steps to set up the Gaussian splatting in my Windows system. So I have RTX 4090 system with me, as you can see here, with 24 gigs of RAM. And so this is the whole process. So first we are going to prepare the image from the video, then we are going to train the Gaussian splatting model, and then we are going to visualize it. And after that, we are also going to import it in Unreal Engine. That part is also what I'm going to show you. So these are the softwares required: Git, Conda, Coda Toolkit, and Visual Studio 2019. And these are the other software: CallMap, Image Magic, and ffmpeg for different purpose. So we can all download that. So we start by cloning the Gaussian splatting GitHub repository and installing the optimizer as they have explained. So we can do all that, and then we have to start preparing our images from the video recorded. So I'll be going through steps one by one. So I'll also open the GitHub repository that I have just cloned, and I have created one bat file with all the commands so that we can easily run everything in one go. We have set up the base directory, input video, output directory. So first command that we are going to run is this ffmpeg command, which takes in the input video. So in our case it is the 1.mov file, and it is going to convert it into the input images, and then also it is going to create a one input directory here, and it will be moving all the JPEG images which are generated by the ffmpeg command into that input folder. So what I'll do, I'll just comment the rest of the bat file and execute the above commands till the part where it is going to create the images from the video. So I have already activated the Conda environment, but in the bat script also I've done that. So for this ffmpeg, we don't need that. We just need to install the ffmpeg in your system according to what they have explained here, and then set it up in the environment variables. So okay, let's get started. So let's run this run.bat command and see what happens. So it is taking in the input video, and it has started to convert that video into images. So as you can see, there are separate images, and the process is now completed. It has also moved all the images generated to the input folder. So this was the role of ffmpeg command. After that, we are going to use the callmap command to convert the input images into a callmap format, which can be then used for the training purposes. So maybe I can open the GitHub repository and show you. So before in the training process, you can see the part to the call map of or nerve synthetic data. So it needs a part to the call map dataset. So we are going to use one of the command, which is convert.py, which is going to take our input images that we just generated and convert it into the call map dataset. So going back to the bat command, I'll just comment the commands which I have already ran, and then uncomment this part where it is going to go to the Gaussian splatting directory where this files are there. It is going to activate the conda environment and then run the convert.py command, which we can also see somewhere here. Yes. So this is the convert.py command, and we can see it is internally using callmap command to generate the dataset that we require for the training. So we are just now going to run this particular command. So I'll just run again the same bat file, converting input images to callmap dataset. So if we go back in this RML office, so you can see there's a new folder created. So this part is going to take some time, 5 or 6 minutes to complete, and we'll wait till then. And also I'll explain the further process, what we are going to do next. After that, we are going to, okay, I'll just comment this out so that we don't get confused. After that, we are going to again activate the same conda environment and run the train.py file. So this training part is we are going to train the Gaussian splat model, which is provided by this repository. And for this particular use case, they have different options So I'll also open maybe the files which I have changed. So internally, like they have set like 30,000 as the iterations, which is like predefined in their optimizer class. I wanted to see like what happens if I increase the number of steps. So when I like increase the number of iterations, I was getting like better output. So we have also like installed TensorBoard here within the repository, in which like we can track our loss function, how it is decreasing with time as we move ahead in the iterations. Also going back to the train.py file, we can see like there are some arguments. Test iteration is like where the evaluation happens. So there is like on 1000 iteration, 68,000 iteration, and I think this is something wrong. It is 60, I don't know what. Okay, so this is the step size, sorry. So it is specifying like so it is giving out a list, and it is saying like on what number of iteration you need to do the test. Then comes the save iteration. So we are saving the model on these iteration, which is 7,000, 38,000, and 68,000. So these are the iteration on which the checkpoint will be created, so that we can also use them later and see the results out of that. Let's see what's happening. So you can see there's 100% of my CPU utilization for running that convert.py command. Let's wait for that to complete. And what else? So yeah, so once this call map dataset is created, we are just going to run this train.py command. I've already trained the model, but I'll just run the train command just to show you guys how everything is working. Once that is done, we'll be going to run the viewer, which is provided in the setup, which we have seen before, and in which like we can see the point cloud data. Once that is done, yeah, so this is the viewer command, SIBR Gaussian viewer. So once that is done, we are going to see like we have generated one output PLY file, and that PLY file now we are going to use one third-party extension to load it up into the Unreal Engine. Okay, let's I think let's keep this process running. I'll show you the output which I have already created before. So this is the AuraML Office 4, same directory, same everything. So this was the dataset which was created before, and now maybe I can use this AuraML Office 4 to show you the training process, because it is I think going to take time. So I'll just change the input directory to 4, in which the call map dataset is already present, and we are going to run this train command so that I can show you what's the output and how this train command is running. So I'll just run this run bat file, which will run the training command on the AuraML Office 4, in which the call map dataset was already prepared. Running Gaussian Splatting training. So it is reading all the camera angles and everything, which is already part of this call map dataset. Maybe we can see in some of the directories. So the camera bin contains all the, I think, the camera positions. These images were also like newly generated. There are around 464 images. Okay, so soon the training process will get started, and in the Gaussian splatting directory itself, so this directory, the output directory, there is going to be one new folder which is going to be created, in which the output of the model is going to get saved once like the training is completed. Okay, so this part is I think taking time. This is the call map thing, and this is the training thing which we are running. Okay, so we can see the training process has now been started, and there's this folder name 192. So let's go and open this 192 folder. So we see like there are some of the files which are saved here, and since in the train.py file we have saved like what iterations we need to say, 7,000, 30, and 60k. So once the training process reaches to this point of 7,000 or 30 or 60k, these checkpoints will be saved into this folder. So again, this training part is going to take a lot of time, around 30 minutes. I'll already show you the model which I have previously trained using exactly the same commands which I have shown you. For now, I'll just stop the training process and directly open the visualizer so that we can see the output. So let's keep all these parts same, and I'll just turn on the visualizer. So for visualizer, we have to run this SIBR command with the with -m flag and giving the output folder path. So in that case, this is the folder. Okay, so the previous training which I've done, in which I was saying like I've trained it for different iterations. So this is the 7,000 iteration, 30th and 60, and all of them have their own PLY file. So PLY file is just a representation of point cloud format in Gaussian splatting. So we are going to use this file for visualizers, and for that we just need to give the output path of this folder. So we'll just copy that. We'll go to the visualizer folder bin. We'll open a new command prompt over here. We are going to use the SIBR exe file -m and giving the path of the output directory which was created after the training process. We are going to click OK, and now here we can already see the output of our train Gaussian splat. So we can see we have this office which we have recorded the video for, and now it is like converted in a Gaussian splat format. We can like go around this area, see all the objects which are there in this 3D scene. We can go at like different places to view different areas. I'll increase the movement speed so that you can quickly go through the entire environment. So right now I'm like using my keyboard keys to like move within the environment, ASWD and JKL I keys to like orient the camera. So yeah, so this was like the second room, and now let's get back to the terrace. And on the terrace you can see like we have our clothes hanging, and we can like move around this terrace to see different part of the video that we have recorded in form of Gaussian splat. So yeah, this is like using these same steps you can also create your own Gaussian splat, and you can visualize that inside the viewer. Now let's go to the next step. So let's say once we have created this Gaussian PLY file, how we can use it to like maybe import it in Unreal Engine and visualize it and maybe use it for different purpose. So I'll now close all these things first so that we can easily visualize everything. So now going back to our Gaussian splatting folder where the output was created. As we remember, like there is one PLY file which is created in the 68,000 iteration, and now we are going to use this PLY file to import it within the Unreal Engine. So, and there is like one more step which I did before importing. So I converted or modified this PLY file to remove the extra Gaussian splats which were not required. So for that there is this play canvas super splat editor where I just opened the splat which I created. So maybe I can show you, or for that I'll just create a copy of this file. Okay, so this is the point cloud PLY file copy. I'll open this file. Gaussian splatting output 60k point cloud 60k copy open. So in this editor we can actually open our point cloud which we just created, and if we like reduce the splat size, so we can again go within this splat that we have created and visualize it, and also edit it in this editor that we are seeing here. So yeah, we can like rotate within this environment. So like it's a little tricky to control, but yeah, once you'll get a hang of it. So yeah, we can see like we have the Gaussian splat here, but as we see like there are a lot of other splats which are not useful for us. So in this tool we can use like use this rectangle tools and everything to delete the part which is not required. So you can select it like that, delete the selected splats like that. So I'll also do that and only show the area which is required. Delete selected splats, delete this part as well. So these part is not like required at all. This is like the extra information. Delete, and let's go back to the splat now to see if. So you can see like we have removed some of the extra content, and after like iterating it more, like clearing all the part like such as these and everything, even in the Z direction, we get like one PLY file which I have already saved on the desktop folder. Just to maybe quickly show you. So this is the final PLY file which I have created, and now we are going to import it in within the Unreal Engine. And for that there is one plugin which I found for free which we can use to import it in Unreal Engine, which is Xverse 3D GS UE plugin, and they have specified like all the steps what you need to do. So what I just did is we can go to like the releases folder. Inside the release folder you can find different Unreal Engine zip files. I downloaded this UE5 5.3 zip file and downloaded it within like one of our folder. So I think yeah, this was a file, and then once I extracted it, I then moved it to the plugins folder of Unreal Engine. So if you go to Epic Games 5.3 engine plugin, you can see the extracted zip file. I have just copied pasted here so that it can be used by the Unreal Engine. So once we go to like our Unreal Engine, we go to project settings, plugin settings, and we write Gaussian. So we see this plugin is now already enabled. In your case, it won't be enabled after copying. You have to like enable it, restart the editor, and you'll be then able to use this plugin. And once you have enabled this plugin, you'll be able to see this icon over there. And simply in this, you can import your PLY file to visualize it within your Unreal editor. So I'm just going to click this. I am going to select the PLY file which I have got after editing it from the Super Splat Play Canvas editor. I'll just select, open it. And now you can see Unreal is importing that PLY file into its content browser. I'll minimize or close this part. And there is this new folder which is now created, users, and these are the files which are now created. So if we open this blueprint, we can already see the Gaussian splat that we have created is now imported within the Unreal Engine. Internally, it is using the Niagara system to represent all the particles which are there in the Gaussian splat. But now you can see like we have now able to see our Gaussian splat within the Unreal. To use it within the editor, we just need to drag and drop this into our scene. Right now you're not able to see, I don't know, there is some problem or what. So whenever like I activated this show FPS, it starts, we can start to see the splat. And now we can also see like we can go within this environment, we can roam around, we can reduce the camera speed maybe to easily move within the environment. So this are like the first room of the office, and we can see this is our second room. So we can see like the quality is not that great like what we were seeing in the viewer, but maybe if we like train it for more iterations, we would be able to get a better output. But in all, we can see like we have now used our input video, we have converted in a call map, then we like trained the Gaussian splatting and then imported in Unreal using this Xverse plugin. So just to recap over all these steps again quickly. So this was our like main bat file. I'll just maybe uncomment the part which are required. So these are the variables which I have manually set. This is the ffmpeg command to convert the video into JPEG. Then we moved it into the input folder. Then we convert the input images into a call map format. After that, we run the train command in which we are giving the input folder as the argument. Then we are going into the viewer bin command and then running this sibr exe file and to view the environment. After that, what we did, we went to this super splat editor to remove the unwanted part of the Gaussian splats, create a new ply file, and then using the Xverse plugin to import that ply file into our Unreal Engine. It is going to create like a new folder, and then we can just drag and drop it to Unreal Engine to visualize the Gaussian splat that we just created and use it for any purpose, maybe for like gaming or CGI or virtual production and anything else. So yeah, thanks for watching our video. You can now also create your own video and import it in Unreal Engine using the steps which I specified. Stay tuned for more such updates. Thank you.